I'm Stephen Foskett, the organizer of Tech Field Day, and this is Storage Field Day 11 coming to you from San Francisco. We invite a group of independent bloggers, podcasters, and other IT influencers to come from around the world to discuss and learn and interact with interesting companies. This morning we're at Scality, and if you'd like to learn more about this presentation or any others, you can go to techfieldday.com. If you'd like to see some more videos from this, you can find them at youtube.com/techfieldday.
Hi, everyone. So I'm Marc Villemade. I'm the architect for the US. I'm going to talk more about the file system aspect of things, since Giorgio has been talking about S3. So I'm going to skip this. I'm just going to, because we talked about this earlier, I'm just going to mention that the scale-out file system is what we call our native file system. And that was created back in 2013, where we had built the object store first, and a lot of our customers were asking for a file system interface to this. And at the time, there was a lot of options. There were a lot of options like gateways, but we wanted to bring something a little unique where it's not a gateway, it's a native access where we hold all the information in the ring itself. I'm going to talk about that. So yeah, it is a native file system access to the ring. The idea is that, as I just mentioned, it's not a gateway, really, where data is stored and then it's pushed to the cloud, like you could have with other products that attach to an object store. In our case, it is we have all the information around the POSIX file system stored in the ring itself. So in that case, all the connectors, everything that's exposing a file system through NFS or SMB or Fuse or CDMI are actually sort of stateless, as stateless as a file system connector can be, at least for the data and metadata. So it is, like you say here, we have these Linux applications for NFS and SMB, and for NFS and Fuse, and Windows for NFS mostly, for SMB mostly. And this runs either on the applications themselves or on Windows, and then it accesses the two layers that are here that are used to expose a file system in a scale-out way. So there's I'm going to talk about these two a little later, but there's a software load balancing that we have that allows us to have multiple connectors and fail from one connector to another pretty efficiently without losing connection or losing data transfer. And the shared cache is another system we built inside the ring itself as well to allow for shared locks or being able to have multiple clients connect to multiple connectors and share the same file system. Because I think that was one of the questions we had earlier around how do you manage that if everything is distributed. Any questions around this? Okay. I guess the idea is that really everything that is around the file system is not stored on something else than the ring. So we built a specific database or data structure that we store in the ring itself for the metadata. And that's what allows us to have those stateless connectors. A connector will store the data in the ring using replication or erase decoding, just like a regular object store. It is actually a simple object storage put, get, deletes. And we'll also use the ring, and for that specific ring, we use a flash-based ring. So these machines here hold SATA drives and SSDs. We use the SSDs to create a only flash-based ring that holds all the metadata, because these are very small IOPS on the ring. And it's the same thing. They are replicated, so we have multiple copies. So all the view of the file system is stored in this database that is just basically objects on the ring that we see for us as a logical database. It's not an actual physical database.
Key value store kind of thing.
Yeah, so it's a B+3 that we map onto objects in the object store using all flash. And this is in the same way that the regular data, it is stored in a redundant manner with multiple copies, like many copies for all that data.
Where's the namespace managed from? Is that from the same database as the metadata?
Yeah, so we are using a ring for the metadata, so it's the same model. It uses Cord. It uses the same model to store the data.
Okay.
It's not a specific storage system for the metadata itself. We use the same in another ring. Basically, these machines are running two logical rings. One is a logical ring that holds data and that's stored on spindles. And then there's another logical ring that has its own key space, namespace, a different key space, that is holding all the metadata.
So is the namespace part of the metadata, or is it separate?
So the namespace for the file system and the namespace for metadata is separate. If that's the question. Are you talking about the namespace for the file system,
or
or
shared namespace? So you're saying
shared
it says earlier that the namespace is shared between files and objects.
So the namespace for the file system, this is like I will have a volume, which is a namespace for the customer that is shared across all the connectors. So all the connectors can see and expose that namespace to clients, NFS
so
clients, no matter which connector
I get my connection to.
I thought you were talking about the namespace where we store the metadata, and the namespace, the key space for us, where we store the data. These are not; they're separate because it's two different logical rings.
Okay.
But to the application layer, they see all these applications can see the same volume, whether they go through NFS, SMB, or Fuse. They can also go through CDMI or a REST interface, basically, that allows us to expose data that has been stored through a file system through a REST interface, or vice versa.
So
This is a very, very. Sorry, go ahead.
no, keep going.
I was going to say that model is very popular with media companies that are doing streaming because they have a workload that generates content with transcoding that is typically a file system, and they push that into the ring, and then they have CDNs that come and get data from their origin server, and these guys are typically HTTP based. So they push data to the ring through NFS or SMB with all their content and their editable content, and then an origin server, CDN is going to come to the origin server, which actually is the same machines, just exposing the same volumes through a REST interface in that case.
So previously, Giorgio showed a slide early in his first presentation about the performance profile. Basically, it had silicon sand on the upper left, and it had a large block, and it had sort of tape off to the right.
Yep.
Does this change any of that at all, what you're doing with
No, it's the same.
So it's the same.
It's the same.
This would be the left side of that block that you
Yeah.
showed
Yeah.
more. Okay.
Some archiving tools are still using a file system. Backup tools are still using a file system, even though they're moving towards S3 more and more. But a lot of the media management also is using a file system today, except for origin servers that are exposing themselves to the outside world through HTTP. Okay. But in those spaces, it's still very much a file system space.
So, question. So yesterday we had a presentation from Samba, and we're just kind of wondering now that we know that it's free and used. Is this what you're using for your SMB implementation?
Yeah, the SMB here is Samba, basically. So we have all the features that Samba has to the outside world.
We do Samba over Fuse.
Over Fuse, yeah.
So it would probably be fair to say then, performance-wise, there's a fair amount of latency, but a high amount of throughput.
Yeah,
Yes.
that's exactly it. This is really made for applications that are very parallel in throughput, writing a lot of data or reading a lot of data. It's not made for random I/O. It's obviously not made for a database, VMs, all that stuff. It's really not made for that.
So people using this in life sciences?
We have some labs in the US that are using it. Life sciences, I'm not sure they're using it. They're using it for, some of them are using it for simulations of different sorts. But in the HPC world or highly parallel file system, what happens is we don't replace the GPFS or the luster, but we have ways to be the tier 2 of those things. So with using copy tool and these guys, our customers can tier data from these high, very parallel file system, very, very performant file systems down to us, because there's a lot of that data that's not used all the time, and it's expensive file system. So if they can reduce it by half, then it's great for them. They don't have to buy more GPFS, more luster when they're growing their data. There's a lot of that happening in genetics and also in all the healthcare and pharmaceutical, because they generate a ton of data that they have to crunch, but usually they only crunch a subset of that data. And so the idea also is the way that this is done, because everything is in a very scalable object store in the backend. We also don't have any of the limitations of a file system, like number of inodes or number of directories, folders, number of files in a directory. We can really scale this out to billions of objects, billions of files in a file system, billions of folders, many files in a folder as well.
Might there not be issues on the client side with that?
I haven't seen any system that.
I mean, kind of, like a Windows box or a Mac mounting a NFS
on the
like,
end
holy
user
shit,
side.
there's 4 billion
Probably.
files in this directory. give me an hour while I'm sorry.
Probably,
give me an hour while.
Windows or Mac would probably not like a folder
Okay.
with a billion objects.
But from a server perspective, maybe not. Okay.
On Linux, it's usually not a problem.
We actually have a config file of what size you want to report.
Yeah, also, yeah.
What was that?
We have a config file about how much size we want to report.
Oh.
Because, so
Yeah.
sometimes it's just too much.
Interesting.
Yeah, because we have seen, so when this started, we were not reporting the actual size of the file system. There was no way to say this is a file system of 100 megs or 100 gigs or whatever. It was giving you the entire file system, the entire capacity of the ring. So you would have we'd do DF or Windows, it would say 4 petabytes. Ooh, I don't like that. This file system is too big. So we changed that so that you can set it in the configuration file, say, or when you create the volume, this volume is this way. And now we also introduced recently quotas on volumes and all that stuff, which also basically resolves that problem, because we now have a volume that knows it's supposed to be 100 terabytes or 5 petabytes if you want.
Is there a limitation for a single file size as well? So what's the maximum file size that you can store on?
There's no file size limit.
There's no limit on the.
Yeah, it's and that's because of the way that all the information is stored in that database, and we can. And it's not a database, that the metadata layer that we have, and we can just add more. Like a file for us is it's a sparse file for us in the back. So we just add stripes to it when you want to add more. So. And getting the information around a file that is 3 petabytes or 30 petabytes or 1K is really just, I'm going to read that B plus tree. I'm going to go into it and read all the stripes, and I can read it back and I can write it. It's really not a problem.
Okay.
The funny anecdote on this one is for one of the labs, we had a 2 petabyte file because they keep writing into a file. It turns out that ls on Linux actually has a P suffix. So he was telling you 2 petabytes. So he knows how to manage it.
Okay.
Yeah, Linux knows how to manage that. We released a new version of the ring back in July or in June that had a lot of enhancements on the file system side. There's quotas, volume quotas, and other things that I'm going to talk about now. Also, all the failover mechanisms that I'm going to talk about here. And also, we have had a lot of work being done with partners around certifying their applications on top of our file system. We did the same thing with S3, but some of these guys are still very much in the file system space. Milestone, it's a CCTV partner. Elemental, they're in the just-in-time play, or in the media streaming world. And so we keep adding to the file system product along the time since 2013. But so one of the things that I mentioned earlier is the failover and load balancing. So we build this so that you can have as many connectors as you want, and like I said, any clients can go to any connector. So this says NFS, but it works for NFS and SMB. Fuse is a little different because Fuse by nature runs on the application side where your application runs, so there's no real need for that. But for NFS and SMB, this works the same way. So we have basically a layer here that handles VIPs and knows how to move a VIP from one machine to another when that machine failed. And this is done through, we have our own DNS server, and you just basically delegate a zone to us, and we can answer to nfs.mycompany.com with the right VIP for you, which is the one that is obviously available, but also has the less load, and it will be able to handle your request better. As you know, NFS and SMB it's not like a REST interface where you could hit multiple connections at the same time. Once you're connected to one VIP, you're staying there. But we will manage, if that VIP goes away and your NFS connection is still there, we'll just move that VIP, and the way that NFS clients work, they will stall for a while, but they will resume the traffic after that. SMB is a little bit different because on the client side, they usually crash the connection when this happens. But there are some advancements with SMB, Samba 4 and SMB 3.1 and Windows 10, where this is going to be handled like NFS, where they'll be able to just, okay, something's wrong. I'm going to try again. I
should have asked this a previous one, but SMB being stateful, how does that work with stateless connectors?
I was saying that SMB, the NFS connector, the stuffs connectors are somewhat stateless. They're stateless in the fact that all the information around the file system is on our end. So the connection is not stateless between us and the application. But if that connection breaks, you can just go to another one, and that connector can see the same state in the file system, except for what was in flight, basically.
Okay.
But everything that was in the SMB or NFS connection before the crash that was committed to or act to the client is now in the ring itself. So if that connection moves to another one, that connector can see the same file system in consistent view. So that's the difference. It's stateless to us in the fact that any connector can see the same thing as long as the transaction has been completed. But of course, it is a stateful connection to the client. Yes, I mean, it's pretty straightforward. It uses another distributed quorum system to handle all these VIPs and IPs and make sure that they are, which ones are available, which ones are loaded, and all the state of these VIPs or IPs.
Do you have any customers who have only taken your software for the NFS piece and have not bothered with the object side?
Yeah, I think it's 50 or 60% of our customers are using only file system.
Really? Wow. That's a big number.
That's interesting.
Yeah.
It's just the clients. They don't know how to write tests.
I think it was actually more 2 years ago. And the enterprise, I think the enterprise 2 years ago is starting to be more educated around object storage and around S3. And then they started moving off some of their workloads to S3. But it's still an ongoing process. And there's a lot of enterprises who have applications that cannot move to S3. Not yet. Right. And some applications that are 20 years old that they don't even know who the developer is anymore, and they can't move it off.
Right. But as a positioning for you in terms of marketing, makes it difficult, doesn't it? Because people would look at you and think you're an object store company, but you're saying 60% of their clients don't have anything to do with the object store side of things.
I think that what's interesting is that there's 60% of the clients that are using a file system, but probably the 40% that are using object are also much bigger in capacity.
Right.
So it's a different. I mean, we have a lot of customers who are using file systems that their total capacity is a lot lower than who's using it.
Two different markets completely.
But having something like this there would then, in a sense, future-proof them. So if they're using NFS now for their backend, and as they start to rewrite their applications to use object store, they don't have to go and get another setup. You can just expand this out and start using object store and free up your NFS side. And
also, you can also use an object protocol and a file system protocol in the same ring. We have customers who have applications running NFS, ND, different volumes on one ring, and also S3 and object on the same ring. It's not you don't deploy this for just file or just NFS or just SMB. You can do whatever you want.
And we have a lot of POCs where somebody has one application they want to use, maybe it's file, but they're also going to test the object side because they know that they're going to need both eventually.
Yeah. Anything else? Yeah.
So is there any difference in terms of your backend storage efficiency using file on an object store rather than a traditional file store?
You talk about capacity efficiency,
Yeah.
or no? Because basically the underlying storage mechanisms, whether it's S3 or file system, is the same. It's a pure, simple REST interface that uses erasure coding and replication based on the size. So you have, if you store a petabyte object using a file system or S3, it will look really like, it would not really look exactly the same because we stripe files in the file systems, but we do chunk them as well on the S3 side. So it will be the same efficiency. A petabyte file would be looking like a 1.3 petabyte raw on the disks, whether you write it on a file system or an S3 interface.
I was thinking more compared to traditional file system products, like traditional NAS products.
Well, in the traditional space, they would not generate, what they will generate as parities is going to be under the file system with RAID. We don't use RAID at all. So they will still have that parity somewhere else. It just doesn't show. I mean, it doesn't show for us either. When you do an NS, your file is still going to be a petabyte, even if it looks like a 1.3 petabyte.
I'll show you something afterwards, and maybe we'll talk about it afterwards.
Okay,
Not
sure.
on camera.
Anything else on this one?
Yeah, so
Yep.
performance of a single file stream. What's that performance like? Is that tens of megabytes? Is that hundreds of megabytes per second?
So NFS SMB, are you talking on file systems?
File
Or
system, yeah, so NFS SMB.
a single stream, probably going to be in the 300, 400, 500 megabytes per second.
Okay.
Right?
Good.
And the more you add streams and connections, the better off.
Yeah, okay, but it's not that a single stream
No.
doesn't even utilize
If it's a big file, right? If you're writing NK objects, we're probably in that range.
usually big files.
Yeah, if you're writing a big video, you'll be in that range very, very easily.
Okay.
Anything else? I mean, this is something we've added recently too. We've had quotas, but there were user quotas, and some customers wanted volume quotas. For example, to say this is a 100 terabyte volume, and we have hard and soft quotas and reporting on raw and usable, just like we were mentioning. Some customers wanted to know, hey, I'm writing a petabyte file, but it actually looks like it takes 1.3 petabytes or X on the file system. They wanted a way to be able to find that out directly, per tenant, per user, per ring, all that stuff. So I'm not going to spend much time on this unless you have any questions. It's pretty straightforward. There's also undelete. So we said before, we're not doing anything in the home directories or VMs or VDI or databases. So snapshots is something we've looked at for some time, but it just doesn't make sense for us and our market. But what does make sense is undelete for some of our customers who are still using this with applications that can delete individual files, or some of our customers use it as a home directory, but with a very specific workload. And in that case, we've validated that workload and it works. So this is just a way to offer an undelete, a simple undelete, to go into a directory and say, hey, I've deleted that file. Can I get it back? And
What about inadvertently modified files?
that's the next step of this. That would be file versioning.
Right.
So today it's just an undelete. When you delete a file, you can recover it. Next versions will be more in the versioning. Hey, I've modified my PowerPoint. I want to get back a time machine wise. That's next step. But again, this is a really getting even more into the home directory world, which is not something we really want to get after. The S3 versioning and some of the tools that are available over S3 for like mounting a bucket as a drive might be a better option for some of our customers, actually. But it is coming anyway in the next versions. Anything else? I think it's, no, okay. So this was really, this is not file system anymore. The last few slides were on top of the ring itself and the connector layer. This is really more in the underlying beast of the ring, where what we do when we're writing data into the disks. And over time, the last 6 years, we've really worked on this and making it even faster and more efficient to do it. And there's even more enhancements we've done recently on relocation and deletion. So relocating for us is it's kind of our defragmenting. We don't really have fragmented drives, but we write objects in big containers. When we delete objects, we just delete part of those containers, and we need to reclaim that space. And that's relocation, basically. And that's part of deletion. So we've done a lot of things recently to get a lot better performance when this happens, so that it does not impact the production environment as much as it used to. So this is very low level. I thought you wanted to add something.
No.
And the last thing I think Giorgio mentioned this earlier, we have a new way of showing statistics and sharing statistics and polling statistics through APIs, through new dashboards on the system, using Elasticsearch and our own API to be able to get into this all these data that we have, which comes from the ring itself, key space. It comes from the connectors. Their state, their load. It comes from the ring server systems themselves. So kind of top of the system, how much CPU they're using, all that stuff, and everything. All these things can be collected. They are collected through us, but they can be also pulled through APIs, and we can use really beautiful dashboards for our customers to see what's going on and troubleshoot the system, doing the performance tracing that we talked about earlier. See, hey, this request took X millisecond, and these are all, we can stack all the latencies from the application to the actual disk I/O that we're doing. And this is done through these dashboards. Any questions on this?
What kind of granularity can you get on those metrics for like I think sets?
Can be I think it's down to the second if you want to. That's very expensive.
Yeah.
But it's down to the second.
Okay.
Plus 1 million.
What happens if somebody gives you a bunch of disks that were in a running system? Could you reconstitute a node from the contents within the metadata within the structures on disk?
If we get just one disk for one.
No, say somebody came along and said the server completely crashed and all they've got is all the disks, and they pull them out and put them in another server.
That's enough. Yeah.
That's enough.
All the data is on the drives. All
You
the
can
metadata
reconstitute everything from the metadata and everything that's already on disk.
Yep.
Absolutely. So it's been a long time. We had a motherboard fail, but if that happens, you can just put the drives in another machine and start.
Yep.
It's like self-identifying, I guess, in some respects.
Yeah, we use UIDs to identify the drives, and then we can just remount them where they were before, the same mount points, and then it's all the state around where the objects and all of that is persistent, so we know, and we can recreate. And worst case, all of that could be recreated by rebuilding the data.
Right.
Because it's somewhere else, either a replica or regicoding.
So you could use that as a shipping method. If somebody said, I need to move a load of data, you could just pull the disks, stick them in a server.
Yeah, if someone wants to, for example, they want to extend their ring to 2 locations and do a stretch, they could do something like that. Like, I'm going to take off half of my ring, if they can, in terms of performance and capacity, move it to the other side and recreate a ring or expand the ring to the other side. There are many ways to do this, but this is possible.
So how do you buy a licensed product? Do you license a node or terabytes? Or?
It's per usable terabyte. So we don't account, we're a software company, so we don't account for the extra capacity we create for data protection. So if you buy a petabyte from us, if it ends up being 6 petabyte of raw hardware because you're doing 6 copies of everything, it's still a petabyte of license.
Okay.
And then there's a license just for multi-geo, whatever the amount of geos you have. And that includes, that license, whether you have multi-geo or not, includes all the connectors.
Okay.
The only one that is the compliancy connector, since it's a partnership with someone else, so this is not included.
Okay, yeah.
Now you mentioned more detail about the erasure coding.
It's coming.
Yes.
Coming. All right. because that's a very
Next.
final-looking slide there. So.
Yeah.
So there's,
Okay.
I probably shouldn't say this, but there's, we communicate with each other a little bit here, and not necessarily out, but I'm just going to project something. There's some sentiment that that you're competing, especially when looking at the metrics, with Isilon or Accumulo. Do you compete with them? Are they companies that you run into very much? Because I wouldn't think actually that you've got the performance to match them.
So, without sounding like arrogant, we actually beat Isilon on performance most of the time.
Really?
Yeah. On video throughput, it's
Yeah, so I would just...
If it's the right
Throughput,
application.
not on I/O.
yeah.
Right.
No, no, IO.
Single
Exactly.
stream.
Throughput.
On throughput.
Yeah.
We never see Cumulo. We have never seen them, but we see Isilon a lot. And each time it's a video use case that needs a lot of throughput, we are much faster.
Yeah, okay.